Okay, the last thing that we're going to go over is we're going to talk about the question, when can I guarantee that I'm going to have extreme values? When we've seen some examples where we don't, we occasionally have absolute maximum or have an absolute minimum, but sometimes we don't have them, like the example of x squared. We didn't have an absolute maximum. So when can I be guaranteed that I have an absolute maximum? So the following theorem gives us some conditions that'll tell us when we have one. These are not explicit if and only if conditions, but this theorem is called the Extreme Value Theorem. And again, the word theorem in mathematics just means true fact, something that we can prove. So the Extreme Value Theorem. So what this theorem says is that if we have a function, if f is a continuous function on a closed interval, then f has an absolute max and has an absolute min. So then f attains an absolute maximum value and an absolute minimum value in that interval. So one of the key traits that will guarantee that we'll have an absolute max and an absolute min is if you have a continuous function, so a function that's continuous on a closed interval here. Okay, continuous on a closed interval. So that's a, be sure to remember that. If you're continuous on a closed interval, then that forces you to have an absolute max and absolute min. Now that's not the only time you have an absolute max and an absolute min. Let me show you an example. So let's first take an example of a continuous function on a closed interval just so you can see what's going on here. Let's look at, for example, sold my red pen there. So for example, if I take some continuous function, so let's take the interval from a to b, and let's just take some function and we're going to make it continuous, so I'm not allowed to pick up my pen. And you notice, yes, this has an absolute maximum value and an absolute minimum value. So at some point C and at some point D, we have some largest and smallest value. Now that doesn't have to happen right in the middle. It could happen on the ends. So for instance, if we had some function like this, then my absolute max is here and my absolute min is here. Notice this isn't saying anything about local maxes and mins. This actually has no local maxes or mins, but it does have absolute maxes and mins. So this is just a statement about extreme values, about absolute maxes and absolute mins. But again, being continuous is not a necessary condition in order for this to happen. So for instance, if I had this interval from a to b and I went like this, notice this isn't continuous, but it still has an absolute max right here, and the absolute min is actually right here at b. So all this is saying is if you know you're continuous on a closed interval, then you can be guaranteed that you have an absolute max and you have an absolute min. Okay. Watch what happens. There are times, let me show you an example, like I could do something like this and have a vertical asymptote there, and then go like that, and there I definitely don't have an absolute max or absolute min. So if you're discontinuous, you don't know what's going on unless you have more information. If you're continuous, you always know that you have an absolute max and you have an absolute min. So that is going to help us when we get to the second half of this section 4.1, when we're actually starting to try to look for those absolute maxes and absolute mins.